رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي.
Assalamu alaikum, dear students. Today I am going to start the very first lecture of e-learning session, and we are going to start unit number 11, which is about electrostatics. And in today's lecture we will cover the first topic of this chapter, which is about the properties of charge and Coulomb's law. To start our lecture, I would like to share a quotation with you. Never give up because great things take time. First of all, let's see what does the word electrostatics mean. We can divide the word electrostatics into the two words. The first one, electro, which means charges, and the second one, statics, which means at rest. We can define electrostatics as a branch of physics in which we study the charges that are present at rest. Now, starting from the properties of charge, we know that similar charges repel each other while the opposite charges attract each other with a force, and that force in general is called the force of interaction, because this force could be the force of attraction for the opposite charges, and this force could be the force of repulsion for the similar charges. The charges are of two types. Either the charge could be positive. The charge on a proton is positive, while the second type of charges could be the negative charges, and the charge on an electron is negative. Overall, atom is electrically neutral because it consists of equal number of protons and equal number of electrons. The SI unit of charge is Coulomb, and the charge on an elementary particle in terms of Coulomb is equal to 1.6 cross 10 to the power minus 19 Coulomb, while this is the charge on an elementary particle. Charge has a characteristic, that is, it is quantized. Charge exists in the discrete packets. It means it does not have the continuous values. It is the integral multiple of the charge on an elementary particle, where Q is the charge on any material, while N is the integral multiple and E is the charge of an elementary particle. An information for you: when you charge up your body by touching the Graaf Generator, your hair stands on end. The hair stands because all hair gains the same electric charge, and we know that the same charges repel each other. So the force of repulsion is so great that it exceeds the weight of each hair strand, while your arms do not lift away from your body, even they have the same charge as your body. This is just because of their heavy mass. Just because they are heavy, so they do not lift up, they do not lift away from the body. Since the mass of the hair is less as compared to the force of repulsion, so the hair strands move away from each other. The quantitative measure of force between two charges was first made by Coulomb. He carried out series of experiments to measure the force between electric charges using an apparatus known as torsion balance. This balance consists of the spheres on which the charges are provided and the force of attraction and repulsion was measured. And after performing the series of experiments, he was able to propose a law, and according to his statement, the magnitude of the force between 2-point charges is directly proportional to the product of magnitudes of the charges and inversely proportional to the square of the distance between them. If we consider the two charges Q1 and Q2, they could be the similar charge, they could be the opposite charges. So according to his statement, the force between the 2-point charges is directly proportional to the magnitude of the charges. Mathematically, it is given by equation A. And the second part of his statement is the force is inversely proportional to the square of the distance between them, which is given by equation B. So by combining equation A and B, we get F is proportional to Q1, Q2 and inversely proportional to R square, where Q1 and Q2 are the magnitude of the charges while R is the distance between them. Get a constant, and in this case K is the constant of proportionality and its value depends on the medium between the charges and the system of units used. For the direction, unit vector along the line joining the two charges is used, and as a result, if we want to find out the force on the charge Q2 because of the charge Q1, we can write down the force as F21 is equals to K Q1 Q2 over R square along with the unit vector R1 of 2. While if we want to express the force on the charge Q1 due to the charge Q2, then the force F12 will be equals to K Q1 Q2 over R square. Now the unit vector reverses its direction and it is R21. So from the figure you can see that the force on the two charges, on the two similar charges, is equal in magnitude but in opposite direction. The unit vector R12 is equals to negative of the R21, so we can express the two forces as F21 is equals to negative of F1 of 2. So we can say that the two forces are same in magnitude but opposite in direction. While we can express the constant K as 1 over 4 pi epsilon naught. An experimentally measured value of epsilon naught is 8.85 cross 10 to the power minus 12 Coulomb square per Newton per meter square. While substituting this value in the equation of the constant K, we get its value, which comes out to be 9 cross 10 to the power 9 Newton meter square per Coulomb square. And epsilon naught is the relative permittivity of free space. So now we will discuss the Coulomb's law in material media. What will happen if an insulator is placed between the two charges instead of the air or the vacuum. So if we place an insulator between the electric charges, experimentally it is observed that it reduces the Coulomb's force. While there is a term permittivity, permittivity is the property of the medium which affects the magnitude of force between 2 point charges. The force in the presence of the medium can be written as 1/4 pi epsilon q1 q2 over r square, where epsilon is equals to epsilon naught times epsilon r, where epsilon is the permittivity of the medium. So while taking the ratio of the permittivity of the medium by the permittivity of the free space, we get a constant which is named as the relative permittivity, or we can also call it as the dielectric constant. Since it is the ratio of the same dimensions, so it does not has any unit. It is dimensionless. It does not have any unit, and its value is always greater than unity for various dielectrics. The force in a medium of relative permittivity is given by 1/4 pi epsilon naught epsilon r q1 q2 over r square times the unit vector r. Since 1/4 pi epsilon naught q1 q2 over r square is this force between the two charges in the presence of the vacuum, so there is only new term which is epsilon r. So we can define the force in the presence of any medium as force between the charges in vacuum divided by epsilon r. So from this equation we can clearly see that with the addition of the medium, which is an insulator, it reduces the effect of Coulomb's force. Either it is the force of attraction or it is the force of repulsion. And sum of the relative permittivity of the materials is given below in this table. So you can see that the least relative permittivity is of the vacuum, then for the air, and for the rest of the materials the relative permittivity is greater than 1. That's all for today, and now your homework is to revise the topic which we have done in this lecture and practice related numerical problems from the book. I hope you have enjoyed the today's lecture, and if you have any question you can write down in the comment section below. See you in the next lecture with a new topic. Till then, take care, study well, and Allah Hafiz.